And welcome back to Jumanji, everybody. So today's task is to identify the two carbon in this pi bond as either electrophilic or nucleophilic, right? Because pi bonds are chameleons and they can act as electrophiles or nucleophile. So I'm going to give you the answer. This carbon atom has neither nucleophilic nor electrophilic properties. This carbon is your nucleophilic atom. And you say to me, how do you know that? Why? Let's rule out electrophile first, right? So right here, in order for an atom to be electrophilic, it needs to be attached by a pi bond to a more electronegative atom, right? And that's not happening here. Now, in order for a carbon-carbon pi bond to be electrophilic, it needs to be attached to an electron withdrawing or electrophilic group. This group, the methoxy group, is an electron donating group, right? Making this a nucleophilic pi bond. Now, the nucleophile will sit on this carbon versus this carbon because when a reaction happens, this carbon will form a tertiary carbocation, which is more stable than a secondary carbocation, right? So when your oxygen will push its pi bond, its lone pair into forming a pi bond right here, right? Your no pi bond can reach as nucleophile and attack an electrophile, right? Causing carbocation to form right here because when a reaction happens at this carbon, your charge is on the other carbon.